So in this video, it's just some examples from the textbook on how to divide surds. So basically, it's quite straightforward. If you have two surd numbers that you are dividing together, you can just take the surd sign over the fraction and simplify that fraction. So square root 15 divided by square root 3 is square root 15 over square root 3, and basically you can just divide 3 into 15, which is 5, and take the square root of that. Okay, so you can do the fraction before you decide whether or not you're going to do anything about that surd sign, or you can just leave it in there if it's irrational. So let's look at some examples from the book. The first one is 10 over 10, square root 10 over square root 2. Basically, we can treat that one as square root 10 over 2, which is square root 5. Okay, so that's the same principle as the previous example up here that I talked through briefly. And the next one then, which is B, is square root 15 over square root 10. So that's 15 over 10 square root all that. So 15 over 10 is 3 halves. We can leave that at that. Okay, and C is a combination with numbers as well as surds, so it's in parts and a division going on there. So if we put that entire thing into a fraction, 6 square root 21 over 8 square root 3, we can treat the numbers separately. So the first thing we can do is we can cancel down 6/8 that we know there's a common factor of 2 in 6 and 8. So there's 2 3s in 6 and 2 4s in 8. So 6/8 simplifies to 3/4. We can also look at the surd values. And so if we just park for now 3/4 at the front, what we've got is square root 21 over 3, which is 3/4 square root 7. Now we didn't have to do it quite that way, but that was the easiest way to do it, and I've just double checked it as the way of the textbook. So that is your final answer for that one there. That is equivalent to writing it, and I'm just going to show you another way of presenting that. 3 square root 7 all over 4. Take your preference. They're both acceptable. The lower one is keeping it as an absolute fraction, just no doubts about it. This one here to me is a little tidier and perfectly mathematical. 3/4 of square root 7. That's 3 times square root 7. Divide by 4 if you read it that way. Still 3/4 of the guy next to the 3. Okay, last one in the set is similar. 5 square root 24 over 10 square root 2. So we can firstly just look at the number part, the clean fraction, and 5/10 reduces to 1/2. So we can cancel that down to a half in that case. Square root 24 over square root 2 is equivalent to square root 12. Now with a half, I can just throw that under 2 like that. That means half of, or square root 12 divide by 2. Okay, so that's incorporating the half into there. The other thing, just to eyeball this and not to try and forget, is that square root 12 is not a prime number as such, and there is a clean square number in there, which is 4. So it's comprised of 4 3s over 2. And so we can treat that as two separate surds, square root 3 over square root 2 over 2. Square root 4 is 2, and square root 3 remains the same, all over 2. And the reason we went to all that trouble to pull that 4 aside and to pull that out is that now allows us to cancel down the 2 over 2. So we've gotten rid of that denominator, and we've simplified that right down to just square root 3. And we wouldn't have actually been able to do that had we not just looked at that 12 a little bit more and been able to pull out that factor.